Hello everyone, welcome to all. So today we are with one new contest which is Codeforces Round 773 and it is going to start right now. Fine. So all the best to you all and yeah, it is going to start. It's an Div 2 contest. So 5 minutes delay it is, but yeah, it is starting. So yeah, let's go to opening. Fine. A little bit slow initial state. So let me open my Sublime also. Sublime 2. So we'll just do this. Okay, and this also I need to. Fine. Little bit slow today, I think. Maybe my problem, net issue would be there. What is happening? Like, yeah, it had opened. So fine. Okay, fine. Cool. So yeah, let me see the first question. What the question is saying. Mm, the downtown. Couldn't. Okay, fine. So Sam lives in awesome work. Its downtown has a triangular shape. Also, the following is true about the triangle. Its vertices have integer coordinates. Fine. The coordinate of the integer are non-negative. The vertices are not on a single line. Not on a single line. Single line. Its vertices are not on a single line. Okay. He call a point on the downtown border. That is the border of the triangle. Safe if he can reach the point from at least one point of the line y equal to 0. Can he can reach from at least say if he can reach this point, okay, from at least one of the point of the line y equal to 0 from any of the. Okay, fine. Walking along some straight line without crossing the interior of a triangle. Fine. So first case, each line containing this the vertices of the downtown border. So 8 comma 10. 8 comma 10. 8 comma 10. So note in this picture the downtown of the first three test cases are illustrated. Triangle are Inherited according to the indices of the test case they belong to. Okay. In the first two test cases, all the points on the border of the nouns are safe. Thus, the answer are 0. Okay. Uh, Next. Okay, okay. These are all are the coordinates. The number of test case. Fine. Each test case contain 3 lines. Fine. Each of them contain two integers xi and yi, coordinate of the vertices of the downtown outer border. 8, 10. Then it is 10, 4, and another one is 6, 2. Fine. So they had asked this picture. Okay. So they had in the, what they had asked. Find the total length of the unsafe part of the downtown border. It can be proven this part are segmented and their number is finite. Find the total length of the unsafe part of the downtown border. Unsafe part. Everything is fine. Okay. Another one 4601. Fine. Okay. The following picture, unsafe point for the third test case. Third test case, let me see. 3, 4, 5, 6. 4, 2, 14, 1, 4, 2, 11, uh, fine. This is, and here, okay, so what they had asked for the third test case, for what is this, like the following picture, unsafe point for the third test case can be marked with black color. 2 is the unsafe. Hmm. Yes, I think every x and y should be distinct here. 0, 0, 0, 4, 2, 4. Let me do this in one note. So let me do fast. So if we take 0, 0, 4, 0, and it's 1, 2, 2, 4. Sorry, 2, 4. So if we talk about this, so yeah, this is fine. 0. If we talk about this, uh, 0, 1, 1, 1, and 0, 0. Okay, so we can find slope slope of any line. Yeah, we need to find the slope of any line. So if we talk about this, slope should be 0. Let me see that whose slope is 0. Fine, that's the thing only we need to find. Fine, and yeah, so we will find all three and slope. So what they ask for each test case, find the total length of the unsafe part of the downtown border. It can be proven this. is finite number. That's only the question is it is 2. Okay, so he calls the water safe if he can reach from point at least one point of the line y equal to 0. Y equal to 0. Okay, y equal to 0. Walking along a street without crossing the interior. Here slope of any line would not be, and for each test case your answer will be considered. Find the total length of the unsafe part of the downstream border. If we talk about the following, unsafe is 2, all the point on the border of the downstream. Okay, fine. So yeah, let's calculate this. Uh, so thing is clear. So what we need to do here? Okay, so let me take L1, comma x2, comma x3, comma y1, comma y2, comma x3, one, comma okay, in x2, comma y2, in x3, comma y3. Fine. We have taken the input. After that, what we need to see, we need to check the slope. M. Fine. So here we are going to check for each and every total how many possibilities are there. Yeah, between these two, and these two, three possibilities are there. So yeah, let me check for this. M equal to 0. Not. Let me. What is this? They said integer, so let's take float. Everything equal to sum is to 0.0, and yeah, float. So here we are going to find out three possibilities are there. So first would be I'm going to see that y1 equal to y2. So in that case we will see then if y2 is equal to y3. So on that case equal to y3, and another one is like y3 is equal to y1. These are the three conditions for checking the what slope. Fine. Yeah, we need to find the slope 0. No? Yeah, for these cases. Okay, so this we are going to find some marker. This is condition satisfied here. And y3, and without precision what it was, let me, I forget about, I think set precision only. Yeah, it is like this. Fix set precision. Yeah, fine. Okay, so here what the precision they wanted, 10 raised to power 9. So let me check it out. Power function. So precision function. Okay, so we used to set the okay and as a parameter, which is the integer argument corresponding to which floating point precision to be set. So before setting the precision using set precision 5 314, so precision 5 345, yeah, to 10 raised to power 9 it will give uh 3 6 7 8 9. Okay, so yeah, let me see that it's working or not. Put it here and okay, fine. 3 6 7 3 6 7 8 9. I think it would work, and yeah, let me check the standing also. It is okay, 2000 submission had been done. Verify, so see. Okay, fine. So I think I need to submit this question. I think it would work properly. And yeah, let's submit this where it is. Fine. So let's submit this question. Wrong answer on pretest 2. What thing? What thing I'm missing out? I'm not getting. So let me see. Section 9. It's really work on this. Let me do this. If I submit this, but it is lacking. The question is saying I'm doing right thing only, no? Your answer will consider correct. It's absolute answer. Fine. Okay. So what is? He calls a point on the downtown border safe. That is, the, its vertices have integer coordinate. Its coordinate of the vertices its vertices are not on a single line. Not on a single line. He calls a point on downtown border, that is border of triangle safe if he can reach the point from at least one point of the line y equal to 0. Y equal to 0 is this x. Fine. Walking along some straight line from y equal to 0. At least he can reach this point from at least one point of the line y equal to 0. He calls a point on a downtown border safe if he can reach this point. He calls a point on a downtown border, that is the border of the triangle, safe. Border of the triangle to be safe if he can reach this point from at least one point of the line y equal to 0. If he can reach this point from at least one point of the line y equal to 0 walking along some straight line without crossing the interior of a triangle. Find the total length of the unsafe part of the downtown border. Find the total length of the unsafe part. It can be proven that this part are segments and their number is finite. This picture, the downtown is marked with gray color. With gray color, the first path is invalid because it does not go along a straight line. Along a straight line. The second part is invalid because it intersects with interior of a downtown. The third and fourth path are correct. Okay. The first part is wrong because it not go along straight line. It is invalid because it intersect with the interior of a downtown. Because it's intersect with the interior of a downtown. Correct. Mm, also point on downtown. Safe if you can reach from at least one point of the line y equal to 0 walking along some straight line without crossing the interior of a triangle. If he can reach this point, he calls a point on the downtown border, that is border of a triangle. Safe if he can reach this point from at least one point of the line y equal to 0 along some straight line without crossing their interior. Downtown border, that is border of a triangle. Safe if he can reach the point, at least if he can reach the point from at least, why it is intersecting this, reach reach the point from at least one point of the line y equal to 0. Okay, if we take this 8 10 8 comma 10 and another one is like 10 comma 4 10 comma 4 and another one is 6 comma 2 6 comma 2. If we take this, so this picture, so we can reach 10, we can reach, and 8 we can reach. Oh, got it. All the points on the border of the downtown are unsafe. These all points are unsafe. 13 minus 11. This 2. Fine. So here I need to change something. It would be, let me take, so it would be what it would be. Be radius of 2 minus 1. Fine. Yeah. And if this is the case, radius of minus 3. And if this is the case, radius of x3 minus x1. So put this out. 2, 4, and 1. Why? Third case, okay, in third case, what it is given? This is the case. 0, comma 0, 4, comma 0. I think we need to handle this case also separately. So y1 should not be equal to 0. And here I will put y2 should not be equal to 0. And here I will put y not be equal to 0. So fine, now it is giving correct answer and I think it would work. Let's submit this also. Okay. Oh, again, why? Here I think it's correct only, no? Why it's giving me wrong? Need to calculate this only, no? This thing only, this part only. Say point for the third test case are marked with black color. Unsafe point for the third test case. What could be the another possibility? Let's see this. If we have like this graph is like this. So in this case, it's fine. What the thing they wanted. The border of the downtown are safe. Thus the answer is 0. For unsafe point for the third test case are marked with black color. Fourth test case all point on the border of the downtown are safe. Fourth test case all point on the border of downtown are safe. I think I really hadn't understand the question. Yeah. The following picture unsafe point for the test case are marked with black color. Let me read the question again. So in downtown, its downtown has a triangular shape. Also, the following is true about the triangle. Vertices have integer coordinate. Its coordinate of the no, its vertices are not on a single line. Fine, not on a single line. He calls a point on the downtown border, that the border of a triangle. Say if you can reach this point from at least one point. Border safe if you can reach from at least one point of the line y equal to 0, walking some straight line. Walking some straight line without crossing the interior of a triangle. Mm, why this first part is what this points are denoting here. In this picture, the downtown is marked with gray color. The first part is invalid because it does not go along straight line. Mm, this downtown of the first test case are illustrated. Triangle are enumerated according to the indices of the test case they belong. The first two test case all point on the border of the downtown are safe, thus the answer are 0. So first two test case all point on the border of the downtown are safe, thus the answer are 0. According to the indices of the test case they belong. 11, 13. Okay, your unsafe point for the third test case are marked with black color. This border we can reach, and this border also we can reach. This both border we can reach. Here also we can reach this border, this border, this border. The thing is, we can't reach this border. Similar thing, if we talk about, we can reach this border, we can reach this border. Fine, we can't reach this border. In every case, it would be, yes, it would be with every case. So what they want the find the total length of the unsafe part of the downtown border. Total length they wanted. Fine. So if any triangle is like this, so yeah, here it would be unsafe part. Everything else they can reach. If we talk about this, they can reach. Oh yeah, there is a case like it would be unreachable. Only those part like if it is like this, or maybe it would be like this. Where the vertices? Okay, 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 fine, fine, fine. Here, one condition I need to put. So, one condition I'm going to put here is like y3. Here, y3 should be less than y1, and here also that y1 should be sorry, y1 should be less than y2, and here also I will put condition y2 must be less than fine. On this condition, we can apply here. So if I do this, fine, it is giving correct answer. Any another case that could be possible? Every case it would be. Yeah, I think now it would be fine to submit this fourth time. And this time I'm pretty sure it would accept it. So again not accepted. Where it's lacking. It's like this. If this is the case, then only we can't reach. Else in every case we can reach. Every single case we can reach. And another one is like, let me see another case also. If this is like this, Here we can reach. This is the case. We can reach, and in this border, yeah, we can reach from here. Any condition they had given that it should be positive number. Awesome. Can reach this point from at least one point of the line, walking along some straight line without crossing their interior of the triangle. Yeah, it is true. No, we can reach this. Another one is like, what if they had given a straight line only? Oof, this part they can. This part they can reach. But this part they can't. Talking about this part, they can't. Yeah, they are. This part they can't. They are. Now what problem is there? Like, I think I covered every case which could be possible. This also. If set precision have no role here, I think. Moreover, what's the role of this precision here? What's the role? Else, what could be? Like, if we do like this, so here, here they can't. Yeah, yeah, yeah. That's the role of precision, I think. It would be that we have this, so they can reach via this. They can reach in this border also, no? Setting that slope, they can reach here also. Yeah, they can reach. Here they can reach. Here they can reach. So they can reach here. Like this, what they did. Here, if we see, I think I did correct only. I don't find any problem here. Seriously means like what the problem it would be next. Or maybe I'm not guessing something is missing. Any test case which could be missable. If I take everything is zero, let's take it. Take every coordinate as zero. Maybe some test case I'm missing. Yeah, this could be a possibility. What could be the next case that could be possible? Zero, zero. It would give me zero only. Currently, I'm not able to find any H case or anything else, so let it be. Oh, people had solved many things. Like, okay, no problem. Okay, I will try to solve second question. Let me see the problem. What the second question is saying? Power walking. Each test case, okay. Each test case. Okay, the second line contain an integer, the types of SAM power-ups. It guaranteed that sum of an okay. For every test case, print an integer. The kth integer should be equal to test case. Print n integers. The kth integer should be equal to the minimum sum of the strength of the children in the team size k that Sam can get. Okay. Sam is a kindergartner and there are n children in his group. He decided to create a team with some of the children to play role go. Okay, Sam has n power up. The ith has type AI power ups. A child strength is equal to the number of different type among power up he has. Okay, for a team of size k, Sam will distribute all n power up to k children. Okay, in such a way that each of the k children receive at least one power up, and each power up is given to someone. Uh, Such that each of the k children receive at least one power up and each power up is given to someone. For each integer k from 1 to n, the minimum sum of strength of a team of k children Sam can get. Okay, 112. On one of the way to get power up to minimize the sum of strength in the first test case is k equal to 1, 112, k equal to 2, 112, k equal to 3, 112. There will to be power to minimize the sum of the strength in the second test case. The kth integer should be equal to minimize the kth integer. The kth integer should be equal to minimize sum of the strengths of children in the team of size k that Sam can get. Let me read again. There are n children in his group. It with some of his children to Sam has n power of height as type. Child strength is equal to the number of. Okay, for a team of size such a way that each of the k children such a way that each of the k children receive at least one power. Find the minimum sum of strength of the team k children Sam can get. If we talk about only one team, so all if we will distribute, so 1 1 2, so minimum only two possibilities are there. If we distribute into 2, if k equal to 2 means it is categorizing into two groups, so on that case 2 4 5 4 possibilities are there. Okay, second. Okay, strength of a team is 2. First strength is 2 because two distinct elements are there. Second strength, first only 1 plus 1 2. Third 1 plus 1 plus 1. Okay, cool. If we talk about second one, 1 2 2 2 4 5. So if we gonna calculate this, so how many distinct element are there? If we take in first group, minimize, we need to minimize the sum. Here we need to minimize the sum. We need to minimize the sum. So it would be 1 plus 4 4 and okay, divide it into four. 4 times 4 will come 5 and 6. Okay. Uh, and if we see the time complexity, okay, fine. So how could we do this? That's the main thing we need to think. Set, we can take a set in which we will count total distinct elements. Yeah. How would we our greedy approach? Listen, we will take all elements inside a map. Then we will make a vector in which we will means sort the things in on the basis of number of frequency a number is coming. If the case like 3 is coming 5 times, so we will take 3 as 5 times after this, after this, after this. Like this, we are going to make an array in well mannered, sorted manner. After that, what we are going to do, we are calculating for k equal to 1 to all n. Yeah, this would work. Uh, hmm. On the basis of frequency, we will distribute whose frequency is maximum, that will come first. Yeah, we could make a vector whose frequency is like that. We could make or not. That's the point. Let's make the array vector that first. Let's make the array vector. Okay, so fine. Let's make that one. So if I do, would be like fine. After that, I'm declaring an what we can say. Vector. Okay, and also declaring a map. Hmm, fine. I had counted the frequency of each term. Hmm. I had counted the frequency, and what next I'm going to do is like for AI vector of declaring fine. Set this what going to put the values. So we dot will take x second frequency, comma, first one. Okay, matters. After that, what I'm going to do is like dot that we begin begin. Uh, I'm going to start in descending order. Re fine. Okay, after doing this, what I am doing I equal to 0. So I plus b dot size and plus what I'm going to put. I'm declaring and we can declare only okay. Let's declare this. Let me put here for lf j equal to j equal to what? J equal to uh b of I dot b of I size. Oh no. We dot first and j plus plus. Here I'm going to pk dot vk dot pb would be p of I dot second. I inserted this frequency, it's denoting the frequency and that much number of times it will go inside this. Fine. Yeah. J0 to P. Let me put some charger here. Okay, it is nice. Let many time it had inserted. So we have our what vector. So we print a vector, new vector. Okay. Yeah. So let me see our vector how it's looking. So if I okay, no problem. Here it is. Everything is cool. So yeah, we have our vector. After this, what we need to see is like this type of things we had. So number of distinct element we need to find out. For that, what we need to do. So declare another vector whose v of j till n it will and vj of 0 till 1. Fine. 0 so going to L of I be less than I plus plus to see that v of uh, what v now vk of I equal to vk of I minus 1. They are equal. So on that case, no need to do anything. On that case, v of I va of I should be equal to that count only. Not one. That this is count. Then count equal to 1. So let's declare that only. Else, if not, so count would have changed. So else count plus plus vj of I will become fine. So like this, if I do, and after this, I will print this v. It's like prefix only. So I'm printing this text. Okay, let us print this 1 1 1 2 3 4. Nice. So yeah, we have this also. After this, let me take for every k, I equal to is going from where k is going from ln. First of all, I am taking another vector vn, which is it will go like this. L k equal to 1, so k less than equal to n, k plus k less than equal to n. Fine. Here, what the thing is that we have n. K. So from what? When everything is distinct. Fine. So so it would be P of j of k minus case. Let me take k as first it is going. So LL LL is equal to pj of n minus k. So on this case what? And here vn I vn of vn dot v sum like this. So first of all, it had 4 distinct elements. Okay. After that, what? After that, it had 3 distinct element plus 1. n minus k plus n minus k plus 1. If k is 1, so total 4 elements, total distinct element it would give. If k is 1, so total 1 group is there. So plus k. It would be that if plus k is there, sure, 1, and it would be minus 1 of like this. So okay, it valid. Then in case of 2, so in case of 2 it is giving 3 minus 1 2 plus 2 4, and yeah, I think it would be right for all the things. If I'm printing on x and output cout cout. So if I am printing this 5 6, right, and I think if I test for this output, so yeah, it is giving correct answer, and yeah, I think it would be a correct answer, correct solution for this question. So let me submit this question. Okay, wrong answer of pretest 3. Let me see. We are lagging with any of the edge cases or not? If I see here, pretest 2 it had passed. Mm, okay, one of the ways to give power up to minimize the sum of the strength. Okay, so where we are lacking? Somewhere maybe we are lacking till here. It's the concept is fine. Like how much the frequency would be, so that much priority we are giving to them because at the end only one it will show to us. Fine, like still here everything is great. VK we have, then VJ we find out the cases, how many distinct elements are there, so we had find out that one. So on the basis of that we had made a prefix array in which we counted for every index how many distinct element are there. Yeah, that's correct. After that what we did, we take an nvn and from k equal to 1 to n, when there is one group, so k1 plus total distinct elements that is, so it's two. Yeah, I got something. Hmm. There is a case, one case sure. Not getting like where we are lacking in this. As per mine, it is should not lack some anywhere. Kth integer should be equal to the minimum sum of the strength of children in a team of size k that Sam can get. The kth integer should be equal to minimum sum of strength of children in the team of size k that Sam can get. The kth integer should be equal to the minimum sum of the strength of children. Distinct also we had calculated. I am seriously not getting like what the problem it is. Mm, let's see the C question also. Grade sequence. A sequence of positive integer is called grade for a positive integer x. Each line is just contain multiple test cases. The first line contains a single. Okay. First line test case to integer n comma x, n comma x. Next line contain n integers. For each test case, print a single integer, the minimum number of integers that can be added to the end. This case to the end of a to make a grade sequence for the number x that can be added to the end of a to make it a grade sequence for the number x. Sequence of polynomials is called grade for a positive integer x. If you sequence of positive integer, wait a second. Hmm. His approach is also similar. Fast. Is called grade for a positive integer x. If we can split it into pair in such a way that in each pair the first number multiplied by x is equal to the second number. More formally, a sequence A of size n is grade for a positive integer x if n is even and there exists a permutation p of size n such that for each this Sam has a sequence A and a positive integer x. Sequence A and positive integer x. Help him to make a sequence grade. Find the minimum possible number of positive integers that should be added to this sequence to make it grade for number x. So the first line contain n and x. Hmm. Okay. This is print to the end of A to make it a grade sequence. Okay, in the first test case, Sam got lucky and the sequence is already grade for the number 4. You can divide it into pairs, such pair like 1 comma 4 4 comma 16. Yeah. Second case 1 2, then 2 4 7 14 7 2. The second case you can add one number 1 and 14 to the sequence. Then you can divide all 8 integer in such a pair 1 2 1 comma 2 1 comma 2 2 comma 4 7 comma 14. Okay. So we are gonna insert this in a map and check that for 1 2 is possible. Yes, it is possible. Possible for 2 4. Yeah, it is possible. For so for that we will arrange 4 and okay. 7 1 2 4 7. Great. Okay, so we have this thing. How we can find this? Okay, so 2 3 6. No, 6. No. 10. 30. No. 10, 100 is there. Yes. 20. 200 is there. Yes. Fine. So yeah, I had a solution for this. So let's code for this also. Okay. So it would be n comma. So that what I need to see is like a bit color. A I plus x a of I. After that, what we need to see in a of I. I had to let insert this in a map. A of I. For checking the frequency of this, yeah, I inserted this. After this, what rest work that will do. So, um, so if we talk about this, so like this, it will go that if x, yeah, wait a second, let me put this as s dot insert a of I. I did the things correctly. After that, what I need to do, like auto saying that if x m dot x dot x dot what it is ll well equal to n of m of comma, let's take that z, let me take this as a z, and here I'm seeing that m of z star x. If this is the case, I taken. After that, what I need to do is m of z minus equal to well m of z star x minus 2, and yeah, that's the thing. LL sum equal to 0 for all at m. So I'm going to calculate x dot second sum plus equal to x second. So I see out equal to end. So yeah, let's do it. Let's see, this is seen nx. Okay, I didn't declare x. Okay, so 233. I think it would be correct. So let's submit this code. Yeah, first of this. Okay, wait. Let's. I'm coming. Just a minute. Okay, so till that time we have some time left. Uh, Let me see the first question where we was lacking. If I had wrongly interpreted the question or not. So hard ways. This question was saying Sam lives in Awesomeburg. Its downtown has a triangular shape. The following is true about a triangle. Vertices integer coordinate are of vertices are non-negative number, non-negative, and its vertices are not a single line. Vertices are not a single line. What does this mean? Yeah, means okay. He calls a point on a downstream border, that is the border of a triangle. These all are border of the triangle. Safe if he can reach this point from if he can reach this point if he can reach this point from at least one point of the line y equal to 0. Safe if he can reach this point if he can reach this point from at least one point of this y equal to 0 means from any x coordinate means like from any of the this y equal to 0 x coordinate walking along okay the line y equal to 0 walking along some straight line he should reach via some straight line without crossing the interior of a triangle. So like this he can reach this is correct. He can't do like this. So and here it is impossible to go here, but here it is possible. So without crossing the interior. Okay. Find the total length of the unsafe parts of the downtown border. Length, we have to find out the length, which is unsafe. It can be proven that this part are segment and their number is finite. Each test case contain multiple test cases. Okay, and each test contain. Okay, let me see. D hadn't any. Okay. What? Okay. Okay. So single answer. I did things. Picture the downtown of a first three case test case are illustrated. Triangle are enumerated according to the indices of test case belonging they belong to. In the first test, two test case, all point on the border of the downtown are safe, thus the answer is 0. Because I know and we all know that um, every coordinate also positive. So this is yeah we can reach here also. Yeah, but here we can't. Whenever the slope is 0, or we can say that whenever this y means it is lying in some y, and it's like this, that y3 is less than this. Fine. On that cases, this thing is happened. Unsafe. Yeah. We need to count the border only. So I did the same thing only. I had taken the answer is that only, that here if we take this, both y is same, and if y3 is less than this, so on that case it should follow the condition, else sum is 0. Everywhere it is possible to do this. uh, so where it is lacking? Okay, where it is lacking? Save point for the third test case on mark. What is the test case where we all are lacking? Yes, I am lacking. Points on the border without. Not 0 also xy. Mm, These coordinates are also integer. So why they had set up some set precision? There is something which I am missing. There is something. And as per my sense on this question level, I don't think they would ask such things. I think they would just need the length only. So it is the difference of their x-axis. That's all. Let me recode code this. Mm, Okay, let me open this. Mhm. Some we have, and first I'm seeing how the triangle looks like. This is a triangle, we can say this. Yeah. And what is the condition when these things are like this? Both are equal, and y2 is greater than y1. Both are could be equal. All three are equal, could be equal. It would be. If it is a straight line. Zero answer, no? In that case, 3. And if it is 3 greater than y, then it would be radius 3 minus 1. Oh, damn. Okay. 0. This is the case. Zero answer. Yeah, accurate. But I have y3. Y2 should be greater than y3. Y2 should be greater than y1. If we see this, hmm, this code is also same only, no? This is also same only, but here it is lacking. Let's see if I put here also don't think anything wrong here. Seriously. Seriously, I don't think anything wrong is here. I'm not able to find it right now. Let me last summation of mine in this. Past. Oh damn! How it had happened? I can't. I'm not able to believe that how it had passed. I just changed the else if. Okay, there I think I was lacking. So somewhat good thing had happened at the end, and yeah, means like let's see how much time is left right now. Only 1 minute is remaining. I had also solved the second one. I think I was miss out miss outing something in second one. Missing out something. If same thing would happen with B also, so it would be so nice to see. Okay, so contest is finally over. It was like overall, if I say that it was an easy contest, I I did my mistake means I did like I hadn't read the first question properly. Because of that, I did multiple wrong summation, and after that also I solved the first one at the end because I was missing else if. Fine, that is important. At the end I did. So it was my mistake. I had taken too much time in first question, and after that second also I solved very fastly. Not very fastly, but yeah, I solved using this. My logic is correct. I think I am missing out something in second question, but in third question I solved very fastly. So third question is fine. It was easy. Third question is easier than second question. That's the thing, is that. And yeah, overall for me it's not a good contest because I can score three questions very fastly, but because of that first question I spent too much time in first question because I hadn't read the question properly. So you all, I'm saying that read question properly. That's the main thing. Fine. So yeah, that's all for today. uh hope Okay, hope we will. Okay, on 27 we have another contest, so we will meet there. Okay, goodbye, thank you.